Hi everyone, welcome to today's class. So today we are going to see if we can solve a system of linear equations having two equations and three variables. In earlier classes, you have already studied system containing two variables and two equations, system containing three variables and three equations, and you have solved the system of linear equations by applying various methods. Yeah. So for some cases now, like for example, you are solving a specific types of questions in 3D geometry. So where we really have to find the ratio of three unknowns. Yeah. So today's class will be useful for that. Yeah. So let me share my screen and tell you how to do it. Yeah. So if we can solve the system containing three variables and two equations, of course the answer is no. But what we can do, we can find ratio of these three variables. Like for example, if we have the system containing these two equations, a1x plus b1y plus c1z equals to 0 and a2x plus b2y plus c2z equals to 0, where a1, b1, c1 and a2, b2, c2 are constants, x, y, z are variables. And as I said, we can't solve this system, or I can say we can't find the values of x and y and z if number of equations is less than number of variables. So here what we can do, we can find ratio of x, y and z. So this is how we do it. So we can take like x minus y, then z in the numerator. Now look at the denominators. So x by here b1 c1, b2 c2. Okay, and these are elements of a 2 by 2 determinant. Similarly, for minus y, the denominator is the determinant containing a1 c1 and a2 c2. And for z also, we have the denominator containing the determinant with elements a1, b1, a2, b2. And we know how to evaluate a 2 by 2 determinant. So this will give us x by b1c2 minus b2c1 equals to minus y by a1c2 minus a2c1 equals to z by a1b2 minus a2b1, right? So this strategy will give us how to find ratio of x is to y is to z. Now let me take a specific example. Now here 3a minus 16b plus 7c equal to 0 and 3a plus 8b minus 5c equals to 0. We need to find the ratio of a is to b is to c. Okay. Now applying this, the strategy we discussed in this case, xyz case. So we can take a minus b and c in the numerator. Now in the denominator we are going to have 2 by 2 determinants. So for a we have minus 16, 7, 8, minus 5. Okay, the coefficients of b and c we are considering here, and for minus b we are going to take 3, 7, 3 minus 5, and for c we are going to have 3 minus 16, 3, 8. So I hope you followed the pattern here. What do you observe? So whenever we are considering a, so we are taking the coefficients of b and c like this. Similarly, whenever we are taking here minus b, in the denominator we have the coefficients of a and c, and similarly for c also. So it means we have a by, so we are evaluating 2 by 2 determinant, right? So here minus 5 into minus 16, that is 80 minus 8 into 7, 56 equals to minus b. Here you can see minus 15 minus 21. Okay, multiply like this, then minus this. And equal to c by 24, 8 into 3, minus 3 into minus 16 means you are getting plus 48 here. So a by 24, here you can write b by this minus sign, you can adjust in the denominator, right? So in any question, you will be doing that. So you have minus 36 here, and taking this minus sign with b, we can take here 36 equals to c by 72. So we are getting a is to b is to c equals to 24 is to 36 is to 72. And these three numbers being multiples of 12, so we can take out the common factor, or you may write here 2 is to 3 is to 6. So finally we are getting ratio of a is to b is to c. Ratio of these three numbers equals to 2 is to 3 is to 6. So I hope you understood. You can apply. Yeah. Okay, so thank you so much.